So let's take a look at this first problem. We have X-rays of wavelength 0.2 nanometers are scattered from a block of carbon. The scattered radiation is directed at 90 degrees to the incident beam. We want to find the Compton shift, delta lambda, and the kinetic energy imparted to the recording electron. So first we can use the Compton formula, delta lambda, h over me times c times 1 minus cosine theta. Now what I've chosen to do is multiply both top and bottom by c. So therefore I can utilize the constants that h times c is 1240 electron volt nanometers and me c squared is 511 kilo electron volts. And then I can plug in the cosine 90 degrees, and which is 0. Of course, when you calculate this, you get 0.00243 nanometers. Got to remember here that this 511 kilo electron volts in your calculator, you got to plug in 511 times 10 to the third. Otherwise, you'll have an error over here in the decimal place. So then the second part, we want to calculate the kinetic energy. So we have to find, I think it's best to find the energy of the and the energy of the scattered electron. And so here, again, hc over lambda, h times c is 1240 electron volt nanometers. The lambda is 0.2 for the X-rays coming in. So you calculate that, you get 6,200 electron volts. And the scattered radiation has a wavelength of 0.20243 nanometers. So how I got that, again, you know what the incoming X-ray has, and you know what delta lambda is, so therefore lambda prime has to be 0.20243. So the kinetic energy is just E minus E prime, so it ends up being 74.4 electron volts. For problem 2, we have a photon that's emitted from hydrogen atom that undergoes an electronic transition from the n equals 3 state to the n equals 2 state. We want to calculate the energy, the wavelength, and the frequency of the emitted photon. So in part A, we can use the direct formula, minus 13.6 electron volts times the quantity 1 over Ni squared minus 1 over Nf squared, where the N's are the states. So Ni is 3 and Nf is 2. So when you plug those in, you can calculate, you get 1.89 electron volts. To calculate the wavelength, we use lambda as hc over delta E. We can calculate 256 nanometers. And then for the frequency, it's c over the wavelength. So we calculate 4.57 times 10 to the 14th hertz.